let's do a really brief explanation on bonding. Let's try to summarize a different type of bonding, different type of elements relating to the knowledge that you should have from before, and looking a little bit at the diagrams that you need to be able to draw. Okay, so first thing, the very important thing to remember is the type of elements that are present. So we distinguish between non-metals and metals. And that's the first distinction to do. The non-metals are on the right-hand side of the periodic table. The metals are on the left-hand side of the periodic table. They differ because non-metals, they can only form negative ions, while metals, they can form only positive ions. Non-metals, they can form ionic bonds, as well as covalent. We will see what's the difference between them. Metals, they can form only metallic, if they're bonded to themselves or to other metals, or ionic bonds. Okay, that's the main distinction. The reason why they can only form a negative ion, remember, that has to do with the stable electronic configuration. Okay, so is always to get a full outer shell. So positive ions, they will lose electrons to get a full outer shell. Negative ion, they gain electrons. Okay, and here I think would be useful to have a look at the periodic table very briefly to understand a bit more how that works. So let me share a periodic table with you. So metals, as we said, are on the left-hand side. Okay, so are those like, well, hydrogen is not a metal, but right? So we have sodium, potassium, magnesium, calcium, aluminium. All of those are metals. Actually, the diagram here helps quite a lot. The numbers, we don't consider the 18 rule, but just from 1 to 8. So those, remember, the most stable elements because they have a full outer shell. I mean, actually, they have a stable electronic configuration because they have a full shell of electron, and that consists in 8 electrons in total. So those non-metals that are the ones here in green, what they need to do, they need to gain electrons to get the same number of electrons in the outer shell. Okay, and this explains the charges that some of these metals get and the number of bonds. So if we talk about covalent bond, let's focus on that first. And let's focus just on the non-metals. So let's do let's simplify the periodic table like this because we won't look at the other elements anyway. So when a non-metals react together, and we're talking about 2 non-metals together, they form a covalent bonds. Because non-metals, they gain electrons, right? So they can only form negative ions, but they won't bind together if they're true negative ions because same charges repel. So instead, they share electrons. And it's the bond between 2 non-metals. For this reason, just because they cannot bond together if they have the same charges. It's really important that you are confident in understanding that the group number is the same as the number of electrons in the outer shell. So if carbon has 4 electrons in the outer shell, this is what carbon looks like. It has 1, 2, 3, 4. Electrons always exist in pairs. This tells us that carbon can actually form 4 bonds, can share 4 electrons because it needs 4 more to have a full outer shell. If we look at hydrogen, it's in group 1, smallest atom, it has only 1 electron in the outer shell. So how many hydrogens can bond with carbon? Actually 4 of them, because each hydrogen would share 1 electron with carbon. And the dot and cross diagram would look something like this. Dot and crosses, they show the electrons, and it's really important to give dots to one element, crosses to the other element, because this shows where the electrons come from. Okay, so this is how to work out the type of bond. There are some that are a little bit more complex. Let's take, for example, nitrogen. So this is still a covalent molecule because there are two nonmetals bonded together, nitrogen and nitrogen. But to work out the type of bond that it has, we need to think about the outer shell's electrons. That's why it's fundamental that you draw them out separately before you join them. So nitrogen has 5 electrons in the outer shell. How do we draw it? Well, 1 on each side. And then we pair them. We start to pair them up because electrons, they are always present in pair. So this tells you that nitrogen can form 3 bonds. So if you have another nitrogen atom over here, let's give him crosses now. Guess how they will bond together? Well, remember that 2 electrons always join in this share. So how many can they do? 3. So working it out like this separately can help us understanding the type of bond that is present between those atoms, because this tells us that each nitrogen shares 3 electrons. So there are going to be a total of 6 electrons here in the middle. And each nitrogen still has 1 lone pair, because when they're already in a pair, they won't bond. Okay. And this is called a triple bond. Okay, and we can write it as like this. Triple, because this is going to be a single bond, and it can be shown, let me do in the same color as before, it can be shown as just a single line. So this line means electrons, so there is 1 pair of electrons. Okay, so notice 3 means that there are 3 bonds. Okay, so we can work out how they bond by writing them separately and then join them together. Let's do one more example. I'm just going to clear up the screen a little bit. And let's do it the same way. Doing it as if we don't know the type of bond that it's going to be present between those. Okay, so let's take another molecule. For example, I would do CO2, carbon dioxide. So we know that we have 1 carbon and 2 oxygen. We don't know how they're bonded. We know it's covalent because they're 2 nonmetals. So what we can do is draw the first atom is carbon, and we know it has 4 electrons in the outer shell. Then we can draw oxygen. What do we know about oxygen from the periodic table? Group 6, so it has 6 electrons. Look carefully how I'm drawing them out. 1 on each side before they pair up, because this tells us that oxygen can share 2 electrons because we always want them to pair up. But we have 2 oxygen, so let's draw another oxygen on this side. We have again 1, 2, 3, 4, 5, 6. So now we can check, okay, how will they join together? Oh, look, 1 electron from carbon will join 1 electron of oxygen. It's another color, I don't like this one. So these will join, these will join. Same thing for the other, carbon and oxygen. So what do you notice? There are 2 lines in between each, which means that each carbon is sharing 2 electrons with the oxygen, that it's also sharing 2 electrons with the carbon. And oxygen has also 2 lone pairs. So this is what it looks like with oxygen. Again, it's lone pairs. So I hope you understand the steps to take to do the covalent bonds. Let's do the ionic, same thing, dot and cross diagram. So I'm just going to clear this up, and let's now highlight just a few things that we need. So I'm not going to consider the transition elements, and we don't need this part, and we don't need those. I'm going to focus on those two sides of the periodic table. I'm going to keep the noble gases there because that always gives us an idea of how many electrons needs to be shared, gained or lost, because we need to get to 8 electrons in the outer shell. So we have group 1 to group 8. So ionic bond, it's slightly different, and it says the name ion, ionic bond. Ions are charged elements. And we know that this is +1. Like this. So group 1 will form a +1 element because when they lose electrons, they end up having the same electronic configuration as group 8 elements. Group 2 will have a 2+ charge. Group 7, so we said those are non-metals. Remember, those on the right-hand side are non-metals. So these, for example, look at nitrogen. It's 7. The stable electronic configuration would be at 10, so it needs to gain 3 electrons. Gain electron, remember, means that it becomes negatively charged. So this would be 3-, this would be 2-, and this would be 1-. Well, those, they don't react because they're too stable. They have already a stable electronic configuration. So the ionic bond, to show ionic bond, we need to show after the transfer of electron has occurred, because what happens is that, let's do a very simple one. Let's say this is our metal. So this is our metal, and this is our non-metal. Look, Mole is going to draw the dot and cross diagram same way as before. And this is our non-metal. So the metal has to become positively charged. How does it do that? Well, because it transfers 1 electron to the non-metal. But this, we don't need to show it. We need to show the consequence of this transfer. In fact, the ionic bond will be shown as, in a square bracket, we would have the metal, that it's now empty, that the outer shell is empty because it has lost that outer electrons, and it has a charge. We write it like this. While the non-metal, it has still all of its electrons, so it has 3 full pairs, and then now this electron has been transferred to it, so it will end up having 1 lone electron, and this will get a negative charge. This is our ionic bond, okay? Because it's the electrostatic attraction between oppositely charged ions. Just one last example for this dot and cross diagram of bonding. So if, let's say that we have, let's do, for example, beryllium oxide. So beryllium is in group 2. We know that it's going to be a +2 ion, yeah, because it's in group 2. Oxygen is in group 6. We know that it needs to get to 10 electrons because it has 8 in total. So in the outer shell, very important, it has 6. It's going to gain 2 to have a full one. So it has a charge of -2. So how would that look as a dot and cross diagram? Well, beryllium has lost its 2 electrons, so it has an empty outer shell. We don't need to draw all of the others, but we need to put the charge outside the bracket. And what has happened to oxygen? Oxygen has gained 6 electrons, so it would be 1, 2, 3, 4, 5, 6, and it has gained 2. And these 2 came from beryllium, so we need to show them with a different symbol. And it has a charge of 2-. So this, in a nutshell, is how to work out dot and cross diagram for both ionic and covalent bonds. I hope it helps. If not, listen to this again and again until you understand all of the dot and cross and diagrams that I've done.